पे जाना. Let's start. It is our third project presentation, and our topic is Kalman filter based GPS tracking system. My name is Muhammad Abbas, and my group member name is Jasir Naim. Dr. Junaid Qadir is our uh, course instructor, and let's start. Next, it is today's our agenda: introduction, problem statement, Kalman filter and history, literature review, Kalman filter equations, and result references. Next, next. Introduction. Kalman filter is used for stochastic estimation for noisy sensor measurements. Kalman filter is named after Rudolph E. Kalman, who in 1960 issued his famous research a new approach to linear filtering and prediction problems, in which estimation was given. It is a type of estimation known as linear quadratic estimation. It can also be considered as extension of Gauss development of least mean square model to estimate unknown variables of model. Kalman filter has its efficiency due to inexpensive computational requirements and real-time implementation. So, the Kalman filter is a technique in stochastic that use observed measurements over time containing noise and create estimation that are more exact than a single measurement by estimating a joint probability distribution over a time. Next slide. Next slide. Okay. Kalman filter algorithm consists of two steps. Number one, prediction is also called propagation, and update is also called correction. Uh, in Kalman filter, we take some measurements and then process this measurement and predict. After prediction, we get result, and if these results are similar to estimated result, then we pursue our result and process these result again. If these results are not similar to estimated result, then we again predict these result. Next slide. Problem statement. Kalman filter technique can be applied to a variety of applications. One of its application is GPS-based position estimation. We wish to apply a Kalman filter on GPS measurement. Kalman filter is utilized for better position estimate over those provided by direct GPS measurement. GPS used for position estimate is prone to error due to various sources. These errors accumulate and provide wrong result. One of the way to get an accurate position estimate is to include more sensor like inertial measurement unit or some other devices, but all these would not be cost effective. Thus, by integrating the Kalman filter as a post-processing filter, the error can be reduced. Now, I would like to Yasir to continue presentation.
Thank you, Wes. Now I will tell you about the Kalman filter and its state estimations. So Kalman filter are utilized to guess the state based on linear dynamic system. The process model describe the progress of state from time k minus 1 time k. As you see that in the equation xk is equal to this, and as f is equal to state transition matrix and b is the control input matrix and w is the process noise vector. So the process model is combined with the estimate model at the current time step as zk is equal to hx plus vk, as in zk is the observation vector and the h is the observation matrix and vk is the observation noise vector. Now I will tell you about a example which is navigation where the vehicle state's position and speed are measured by utilizing a sensor from a inertial measurement unit and global navigation satellite system. We consider position and speed. And as you can see, there is three-dimensional position speed involves state vector, which is x. The state in time can be predicted by previous state in time k minus 1, as you can see in this brackets. You can as delta t is the step time we use, and the above equation can be arranged as this. Now I will tell you about the covariance relationship, which is this. We use this because we use this covariance matrix because of the lossless noise. So you can see that the Q is equal to the equations of matrix of noise matrix, and process model is becomes this xk is the function of x, and where b and f to this. So you can see that GNS, so receiver gives position and the speed estimate drawn by the measurement noise Vk, which is as the Vk is the noise vector, we can add it and estimate the position speed estimate. Now I will tell you about how we simulated the navigation and speed and position of a vehicle. We use 40 time steps, and with the time size of zero point 0.5, and the initial location and the initial speed is given on the screen, which is 5, and the position is 0, it is a vector. So we pass through a filter, which is the Kalman filter, which gives the values as shown in these equations. In this simulation, we used Monte Carlo's runs because it updates, predicts, and updates and predicts. So, which allow estimations to be acceptable, and it also depend on the each time step we used. So these are the result we came across, that is root mean square estimations and estimated. So you can see that there is a lot difference x position error and y x velocity error, standard deviations. The result also shown that velocity is constant, as we took the uh, velocity constant as position changes with time, and also velocity changes with time, which is estimated by the truest constant velocity acceleration means. So these are the references we used. We used the introduction and integration of Kalman filter and its application, which is by Kim and Yuju. And that's all. Thank you for any. If you have a question, you can ask. Thank you.